Problem 2. In the following right triangles, find the values of the missing sides. Let's start with problem A. We have 2x minus 1, 2x plus 1, and 12. How should we approach it?
I think we should square both legs to get the square of the hypotenuse by the Pythagorean theorem.
Let's do Pythagorean theorem. It's a right triangle, and that hints to us right away that Pythagorean theorem might be useful. So the first leg is 2x minus 1 squared. Second leg is 12. We square it, and we get the hypotenuse squared. How do you solve such equation?
We would distribute all the parentheses and just square 12. So we'd get 4x squared minus 4x plus 1 plus 144, which is x, and 12 squared equals to 4x squared plus 4x plus 1.
And we will notice we have 4x squared on both sides. That's convenient for us because we will not need to solve a quadratic equation. And next we'll cancel things. We'll cancel what matches and we'll cancel ones. All right, what's next?
Now we'll move the negative 4x to the right. So combine both of them. Yep. We'll add plus 4x to both sides. And then we'll get 144 is equal to 8x.
So to solve for x, we now need to divide both sides by 8. Okay. So 144 divided by 8, how much is it?
It's going to be 18.
We can use calculator. We can also do it as 80 plus 64 over 8. If we don't have a calculator, this is 10 plus 8, 18. Okay. Next, we need to find the values of the missing sides. We found the value of x. That's not our answer. We need to do a few more steps to find the dimensions. How do we do this? If we know x, how do we find the length of that leg?
Since we know x, we can just input it into 2x minus 1. So we'll have 2 times 18, 36, minus 1, which is 35.
So this leg is 35, and the hypotenuse
is going to be the same 36, but plus 1 this time, so 37.
And if we have a calculator, we can also double check by inputting this value, squaring 35, squaring 12, and making sure it is in fact equal to 37 squared. So that's part A. Let's do part B. We also have a right triangle in part B. And should we do Pythagorean theorem again?
Yeah.
All right, let's do Pythagorean theorem. However, this time the x squared terms will not cancel, so we will have to do a bit more work. Tell me what to write for the Pythagorean theorem.
We'll have x squared plus parentheses 2x minus 1 squared equals to 17 squared.
So before we write the Pythagorean theorem, we always identify the longest side in the right triangle, the hypotenuse. And that will be by itself, right? And then the 2x squared, hypotenuse squared. Okay, let's distribute.
So we'll have x squared plus 4x squared minus 4x plus 1 equals to 289.
And we notice that the quadratic terms do not cancel. So we will need to combine them and move everything to one side. So we will get a quadratic equation in the standard form of ax squared plus bx plus c equals to 0. Let's do this.
So first we can combine the x to the second power. So we'll have 5x squared minus 4x And then in order to achieve 0 on the right, we'll have to subtract 289 from both sides. So we'll have minus 288.
Yes. So 1 minus 289 becomes negative 288. This is equal to 0. Some people might be able to guess the factorization, but the numbers are quite big. So we are going to use the quadratic formula. Let's review what quadratic formula is. If this is the quadratic equation and we have it in exactly this form, then to find the solutions, what do we do?
We just need to take the values for A, B, and C
And plug them into the formula, right? Let's write the formula first.
Yeah. So yeah.
Remember how the formula goes?
Negative B plus or minus square root of
B squared
plus 4AC
minus 4AC. So this is one of the few things that we have to memorize. I don't really have any good mnemonic for this. So negative B plus or minus square root of B squared minus 4AC over 2A. And first thing, we will identify the values of A, B, and C. So look at our equation and tell me what A, B, and C are for our equation.
So A is going to be 5, B is going to be negative 4, and C is negative 288.
Awesome. So notice we included the negatives as we should. All right. Now, with these values, let's use the formula.
Yeah. We'll have 4. 4.
Negative B plus or minus.
Square root of 16. Plus, since we're going to have C is negative, so it's going to cancel out. 4 times 5 times 288. For which 4 times 5 is 20, and 20 times 288 is 288 times 2, plus,
With a 0 in the end, right?
A 0 in the end.
Let's double it. 200 doubled is 400, 80 doubled is 160, 8 doubled is 16.
So that's going to be 576 and a 0.
760, and everything over
2 times 5, so over 10.
Over 10. All right. So 4 plus or minus the square root. And here, to find the square root without the calculator, that's a bit of work. We would need to split it into prime factors, or we already can use the calculator if you have it. And the square root of 5,776 is equal to 76. So that's our expression for x. Let's find the solutions.
So we'll have 76 plus 4, because we need a positive side, since this is geometry. We can't have a negative value for a side. So we'll have 80 over 10. So 8 is equal to x.
That's right. We'll only take the positive side value. And we know that this side is exactly x, 8, simplified it here. And then for the second side, which is 2x minus 1, what will we get?
8 times 2 minus 1. So 16 minus 1, or 15.
And you might recognize it. It's a Pythagorean triple, 8, 15, and 17. So we know that works. All right, so Pythagorean theorem in both parts of this problem.